So, hi guys. This is Kenji López-Alt. I'm very happy to introduce him. Do you want to use this?
Is that a laser thing?
Yeah.
Yes, sure.
Okay. So he is the managing culinary director of Serious Eats, and he is also an MIT alum. He is really someone I have read a lot of his blog posts, and I'm very excited to have him here today. He's written The Food Lab, Better Home Cooking Through Science, this book, which many of you have or may purchase after this event. It's a New York Times bestselling book. And yeah, his blog, The Food Lab, is also really popular, and it's really awesome. Yeah, so Kenji, go
All right, hi. Thanks for having me here. This is actually really exciting for me because giving a talk at MIT is not something I thought I would ever do in my life. It seems like something my dad or my grandfather would do, but not me. It's also kind of ironic because I think this classroom was the one that I took 560 in, thermodynamics. I don't know how many people here had their undergrad here or are undergrads currently. I took 560 in this classroom as a freshman. This is in 1998, and at the time, all freshmen, like the whole year, was pass-fail. I remember at the end of that semester, my TA for 560 bought me some beer, which I think was illegal, but he bought me some beer, and he gave it to me with a note saying, "This six-pack is because you were the student who had the lowest passing grade in the class." So it's ironic that I'm now talking a little bit about thermodynamics. So yeah, we're going to talk about meat. So this is a prime rib. I'm probably going to cover some of the same points you did, maybe talk about them in a little different way. But this is a prime rib. So whenever I'm developing a recipe, there's always the first step is to do research on sort of the traditional techniques and find out what people want from it. And then I try to identify what are the things that I want in a piece of in whatever recipe. In this case, what are the things that I want in a roast prime rib? For me, that is, I want a nice brown crust. I want it to be nice and brown because those brown things, the Maillard reaction, it creates flavor. It's what makes roasted meats and like bread and roasted coffee, all those things taste good. And then I want a medium rare center because I have good taste. And for me personally, I kind of want those things to be maximized. So I want there to be a big contrast between the exterior, and I want there to be a big, basically edge to edge pink meat on the interior, because that's what's going to maximize juiciness and it's going to maximize flavor. So if we go back again and look at a piece of meat, let's talk about sort of the real traditional way that you would make a prime rib or say a steak. Typically, the traditional way, if you were working in a restaurant or something, at the beginning you would sear your meat. So searing is when you expose it to really high heat. So if you're making a steak, that would be searing it in a really hot pan or maybe over a really hot grill. If it's a prime rib, it would be cranking up your oven really high, maybe 500, 550 degrees Fahrenheit, and letting the exterior brown. And then afterwards, you would then let it finish cooking gently through to the inside. So maybe if it's a steak, you would take that pan, put it in the oven so that you're not cooking directly over a flame or over an induction burner, and you're getting a sort of more gentle heat so that it cooks through to the center. With a prime rib, you would maybe reduce the heat down in the oven. And ideally, you would use a thermometer and, as soon as it hits whatever temperature you want, 130 degrees for medium rare, then you take it out, you let it rest, and you serve it. So when you do this, so a few things happen. You do end up with this sort of bullseye pattern, and the reason is because, shockingly enough, when you cook things, they cook from the outside in. And okay, so why does it look like this? So if we go back and look at the structure of meat, again, it is this sort of we get these kind of muscle fiber bundles. And then all these are kind of, there'll be hundreds of those, maybe, I don't know how many, hundreds, thousands, lots of them. And they're all bound up into one thing. So it's sort of this series of tubes that are wrapped up in like the internet, wrapped up in a larger sheath. And for something like this, so this is a strip steak. It comes from a muscle, it comes from the loin, the longissimus dorsi. So if you, actually, could you come here for a second? Yeah. So, okay, so if you're, here. Okay, so this is a steer. This is a steer. These are the ribs. So there's a section called the short loin here, and the ribs up here. And now there's two big muscles here. Those are the longissimus. Those are the longissimus dorsi. They lie on either side of the spine, and so they run in this direction, which means that all of their fibers are aligned that way, for the reason that Markrete explained earlier. Thank you. For the reason that Markrete explained earlier. So if you take those out, those are huge, huge muscles, and actually that's exactly where prime rib comes from. Prime rib is same muscle. The only difference is that here we've cut it into individual steaks. So if you imagine 20 of these, well actually there's 12 ribs in a cow? 12 ribs? Imagine 12 of these up front, and that's the prime rib, and then behind it the muscle continues on towards the butt. And so if you stack these all together, your muscles are running this way. So that means that, yeah, so this is like the top of the steak, this is the bottom of the steak. So as you're cooking this, you apply really high heat to it at the beginning, and what happens is that they start to kind of squeeze out. So the muscles start to contract, these muscle fibers start to contract, and they squeeze liquid out. And it's sort of like a tube of toothpaste where like once you squeeze it out, it's really hard to get toothpaste back into the tube. But by the way, I kind of talk fast, and I've never done this demo before, so if I skip over anything, or just feel free to ask questions or jump in at any time. Also, if I go off on too many tangents, also just tell me I'm going on too many tangents. Okay, so like a tube of toothpaste, you can't really get the toothpaste back in there once it's been squeezed out. So essentially, you can't uncook a steak once you cook it. And the thing is that the amount that these squeeze together is essentially directly related to the temperature that you're cooking it to. So by the time, so say you have, if you're looking at a cross section of a prime rib, so there's a bone. It looks more like a snail. Okay. Let's say you're looking at the cross section of a really big snail, and you have your meat. So by the time it's 130 degrees here in the center, you're probably at about 140 degrees here, and then these layers tend to get thinner and thinner. So you're 150 here. Here you're like 160, and you're probably out here. You're probably at 190 degrees or so, and that's really, really, really hot. And that's why you end up with this sort of bullseye pattern, and that's what happens when you cook with really high heat. So one of the questions is how do we minimize that bullseye pattern while also maintaining the brownness? So the reason why traditionally people cooked meat this way is because there was this notion that, and I'm sure you've all heard this, there was this notion that searing meat seals in the juices, right? And the idea is that by applying high heat right here, you're kind of cauterizing this surface, right? And it's sort of like putting a cap on the toothpaste, and it's supposed to prevent juices from coming out. And it seems to make sense because you can do the same thing with a blood vessel when you get a wound. It seems to make sense, but it turns out that it's not actually true at all. You don't really sear in juices, and you can see this pretty easily. If you take, say, a relatively thin steak and put it on a grill it on the first side, right? Get a really nice hard sear on it, and then flip it over, and then wait a few minutes. Eventually, you're going to start to see juices coming out of that side that you had just seared. So very clearly, it's not. It hasn't been sealed. Nothing has been sealed in. So once you sort of get that idea out of your head, then it becomes a little bit easier to figure out the way to do things. Here, yeah, okay, so here we go. This is a better indication, a better picture. So if we look at here, you can see the very center is that sort of translucent red, and that's the color of basically raw or rare meat. And then as the muscles tighten up, you get more and more well done. So by the time you're at 160 degrees, you're already well done. And dry. You can also just see from the size. So the rarer you are, the juicier and bigger your steak is going to be, because as the steak, a steak is something like 75% water. So as you push out more of those juices, it loses volume, and you end up with a sort of dry, dense, hockey puckish thing at the end. So, okay, that's a very, very, very tiny graph. Okay. Okay, so we know that the higher the temperature you're cooking at, the more strongly that gradient is going to show. So by the time, if you're cooking, like say in a 500-degree oven, by the time the very center is at 130 degrees, those outer layers are really, really overcooked. If you drop down to a much lower temperature, you don't see as much of a gradient. And if you think about the extreme version of that, if you're cooking in an oven that is at 130 degrees, none of the meat is ever going to go above 130 degrees. So you can get the entire thing cooked through to 130 degrees with no overcooked meat at all. There's a couple problems with that. Ovens, air is not a particularly efficient means of heat transfer. And so if your oven is set at 130 degrees, it takes forever to get your steak, or your prime rib. Well, prime rib especially, it'll take you days to get it up to 130 degrees to the center. So there's a couple of ways to deal with this. One way is to just not use a ridiculously low temperature. So what I typically do is I call it the reverse sear, where rather than starting in a hot pan, I start either my prime rib or my steaks in a relatively low temperature oven. So an oven set at like 200, maybe 250 degrees. And with the prime rib, it'll take about maybe 6 hours for it to get evenly cooked from edge to center. With the steak, it'll take about half an hour. And then finally, after you're done with that, you can take it out. Jack the oven up to 500 degrees or as hot as it goes, turn on convection if you have it, just so that you transfer heat more efficiently, and then brown the outside. And if you do this, and if you actually take identical steaks or identical prime ribs and do this side by side, you'll find that the one that you start in a low temperature oven and sear at the end actually retains a lot more moisture than one that you sear at the beginning and finish in a low temperature oven. You probably can't see that, but it's a few percent. It's enough. But anyhow, further proof that searing doesn't lock in juices. Okay. So now the question is, why do you sear at the end as opposed to the beginning? The reason is because, all right, so if you think about searing, your goal is to trigger the Maillard reaction, right? And that takes a certain amount of energy. There's other things that take energy when you put meat into an oven or when you put meat into a pan, though. And there's basically three big buckets if you think about it. There's raising the temperature of the meat. There is evaporating moisture from the meat, and then there is browning of the meat. And if you look at a graph of like time versus temperature on a piece of meat. So say that's 0. This is 212 degrees, like boiling. And then this is like, say, 400 degrees, where Maillard reactions get triggered really well. So when you start out with a piece of meat, it's not dry on the surface, it's moist, right? So let's say you take it out of the fridge, out of the fridge it starts at 38 degrees, something like that. You take it out of there, and this is just the surface temperature I'm talking about, by the way. So it'll pretty rapidly rise because it doesn't take very much energy to change the temperature of the meat in comparison to how much energy it takes to evaporate the moisture. So it'll pretty quickly rise to right around the boiling point of water. And then it kind of flattens out a long time because you have to evaporate that surface moisture. And then only once that surface moisture is mostly evaporated can you start rising again. And then finally you get to the point where you can start browning it. Now this is a big bucket. If you take it in perspective, the amount of energy it takes to raise 1 gram of water from freezing, say 32 degrees Fahrenheit to 212 degrees Fahrenheit, it takes about 5 or 50. I can never remember my order of magnitude. It's 5 or 50, I think. I think it's 5 times more energy to then evaporate that gram of water. So this is one of the reasons why a lot of chefs will tell you, like, take your steak out of the fridge and let it sit for 20 minutes or whatever before you start searing it. It's almost totally useless to do that. Like, first of all, there's not much room temperature is not that much warmer than fridge temperature, and so when you don't have this really big temperature range, it doesn't heat up very fast. So you can take like a steak like this, which I bought a few hours ago, and it's still pretty cold. Even like with a steak that's about 1.5 inches to 2 inches wide, it'll go, like, it starts out at 38 degrees Fahrenheit. It'll take like 4 or 5 hours before it gets up to room temperature. Even after 2 hours, it's only gone up by about 10 degrees Fahrenheit. So it's not really much of a difference. And more importantly, it doesn't really matter what temperature your steak starts at, because what's taking up energy is not raising its temperature. What's taking up energy is drying out the surface. So with a steak or with a prime rib, it's much more important to have dry meat than it is to have warm meat in order to sear efficiently. And the other thing that's important to note is that there's a big difference between searing and roasting, and that's that when you're roasting, you're basically inside an oven. You have constant energy input, but you don't really have like this huge energy reserve, as opposed to at least not one that you tap into, because I guess you can put your roast directly against the wall of the oven or something and heat via conduction. But in a pan, especially if you have a nice heavy pan that can retain a lot of heat energy, you have a big bucket of energy that you're using at the beginning, and that's why things brown more efficiently in a pan, because you have all this energy that you can very efficiently transfer to your meat. Anyhow, where were we talking about now? Oh yeah, okay. And so the reason why this reverse sear method works is because by the time the steak or the roast is up to around 130 degrees all the way through, the surface is also dried out very well, which means that you can then brown it very efficiently, much more efficiently than you can if it's raw and wet. Another trick, by the way, is that if you take your steak, I bought these today, but if you take your steak and you want them to get a really nice brown crust, you can also just put them on a rack and leave it in your fridge uncovered, so that the surface completely dries out, and then you get a really, really nice sear on them really efficiently. And the faster you can sear a piece of meat, the less of that sort of temperature gradient you're going to have again. What was I talking about? Dry versus wet. Dry versus wet. Yeah, I mean, it's okay. So I mean, it is a little counterintuitive, because the drier your meat is to start, the moister it's going to end up at the end, because you don't overcook as much. Yeah.
How about the amount of fat that's on the surface? Does that also matter if you're trying to get browning?
Amount of fat on the surface of the meat?
Yeah, because imagine if you reverse roast it, the amount of fat is going to come to the surface.
You mean like rendered fat, like rendered liquid fat that gets onto the surface of the meat? It'll actually help it brown better, just because fat will actually distribute heat more evenly over the surface of the meat. So that's why, like, if you're roasting a chicken or something and you rub it with oil, it'll brown more evenly. But yeah, it's not the same as liquid, because you don't need energy to evaporate that fat, which is what you do need. Because fat you can raise to temperatures hot enough to trigger the Maillard reaction. Water you can't. So you really need to get rid of that moisture before you can start filling up that Maillard bucket. Yeah.
How long do you need to leave it in the fridge to be beneficial?
How long do you need to leave the meat in the fridge to dry out, for it to be beneficial? I mean, any amount will be better than none. What I typically do is I salt my meat heavily the day before, and then let it rest overnight. And now, I mean, the reason you want to do that, well, first of all, this is meat that I salted just before the class started, and you can see this is salted, that's not salted. At this point, it's been here maybe 40 minutes or so. Maybe 30 minutes. At this point, you can see that the salt has actually drawn out a lot of liquid from inside via osmosis. And that's not good. You don't want to sear a steak when it looks like that. And maybe we can do it side by side in a bit. But you don't want to sear a steak when it looks like that, because all of that moisture you now have to evaporate. And I think by the end of the class we'll see, but as this continues to sit, it's eventually going to reabsorb those liquids, because what salt actually does is it dissolves myosin, the muscle protein, so it dissolves it so that as the muscle fibers cook, they actually contract less, so they don't squeeze out as much. So this is how something like brining works, where you submerge like a chicken or a turkey in a bucket of salty water. It dissolves the muscle protein in the outside, so that when the chicken subsequently cooks, it doesn't squeeze out as much juice. And the same thing will happen with the steak. And what's convenient about that is because it basically does that in the place where you want it to, which is the surface of the meat, because that's the place that's most prone to overcooking and drying out. So yeah, I salt my meat, let it sit on a rack overnight. Now, so this is useful to know. For a lot of people, though, like spending like an hour or so cooking a steak is kind of a hassle. Like you don't want to have to wait while your steak rests around in an oven for a long time. So what methods can we use to? Oh, by the way. Oh, that's a blowtorch. We'll get there. Anyhow, so this is what happens if you do that reverse sear method. You don't have any of that bullseye. You get medium rare all the way to the end, nice brown meat. that's a sous vide steak. We'll get there in a minute. Okay, so what if you want to cook your steak faster? There's a couple of tricks. The big one is something that I think, again, sort of goes contrary to popular wisdom. When I was working in restaurants, I was always taught that you flip your meat only once. And this is also kind of, I mean, just common knowledge in the backyard. I think people say don't flip your meat once you get it on the grill. But it turns out it's actually, again, not true. I'm gonna cook these two. So this is one steak that I just cut in half. I'm gonna cook them side by side in this skillet. One of them I'm gonna flip only once as it cooks. The other one I'm gonna flip probably every 15, 30 seconds or so. And maybe I'll try and continue to talk while I do that. I've never cooked on this particular burner before, or in this particular pan, so I don't know how well this will work, but we'll see. But right now, by the way, we're heating up a non-stick surface to probably like 500 or 600 degrees, and we're vaporizing all these cancer-causing chemicals. I hope everyone brought your respirators with you in the front row. Yeah, reach under your seat. There's respirators down there. Okay. So I'm going to let this heat up just until the oil starts to smoke a little bit. A lot of people ask me why my recipes don't call for specific pan temperatures, and the reason is because so temperature is a useful measure of what's going on inside your meat, because as you mentioned, there is a measurable temperature, and that's going to have a measurable effect on the juiciness and the appearance of it. It's not quite as useful in a pan because of the fact that the pans that people are cooking with aren't the same. A cast iron pan at 500 degrees is going to be holding a lot more energy in it than an aluminum pan at 500 degrees, just because, aluminum has a higher heat capacity than cast iron does, but it's also much less dense. So usually what I think about, as opposed to just straight up heat capacity and density, is I think about volumetric heat capacity. So for a pan of the same size and same shape, an aluminum pan is going to have a lot less energy in it, even at the same temperature. So that means that that means that cast iron is going to sear your steak better than aluminum is going to. I'm not sure what this. I think this is an aluminum pan with a stainless steel disc to allow it to be used on induction. So measures like that are not particularly useful unless you're using the exact same pans all the time, and unless you're sure that the burner you're using is adding heat to it at the same rate. It's much better for me. It's much better to just kind of use visual cues, and in this case, that visual cue is smoking oil. This oil is going to start to smoke. It's canola, so it'll smoke at probably around 475 degrees or so. Yeah. What type of oil do I prefer? It depends on what I'm doing. I would say I use canola oil more than anything. Is my most common just kind of neutral oil, because it doesn't have much flavor. It's low in saturated fat. It has a very high smoke point, so you can get it hot. There's a lot of things you can do with it. If I'm doing something like deep frying, I want an oil with a higher level of saturated fat, because when you're frying, essentially the more saturated fat you have, the crisper things come out, which is why fried chicken fried in lard or shortening comes out much crisper than something fried in canola oil or vegetable oil. So if I'm deep frying, I'll use peanut oil, something like that. If I'm doing a steak, I'll actually often use butter. All right, we're smoking a little bit right now. I don't know if that's the oil or if that's the vapors from the carcinogens coming out of the pan. But we're gonna put our steaks in here. Yeah, like I said, I'm going to try and continue talking while I do this. Now, so as we're going to see, one of these steaks is going to cook faster than the other, hopefully, I think. You're never sure how live demos go, so hopefully. But if it doesn't, we'll just pretend it did. One of these steaks is going to cook faster than the other. That is, it's going to get to its final internal temperature of 130. Well, let's aim for 125, because we don't have that long. It'll get to its final internal temperature faster than the other, and one of them is also going to come out more evenly cooked. So one question I would have for something like this is, how did the original cooking method get started in the first place, and why did it continue? in this particular case, and those questions are always hard to answer because they're often like a mix of history well, bad information sometimes, and also context. So I think this particular one came from the context of restaurants. In a restaurant, it's very difficult to flip your steak multiple times because you're one cook at a grill and you're cooking steak for 40 people. They're all coming in at different times. So it's really difficult to continuously be flipping steaks every 15 seconds and monitoring all of them at the same time. So it's much easier to just say, okay, this one's done, that's brown on that side, I'm gonna flip it over, brown the second side, now I don't have to worry about it while I do all this other stuff. The other reason is because people like the appearance of the, like if you do it on a grill, you get this kind of crosshatched grill marks, and people like that appearance, which is just kind of, I don't know, like some kind of cognitive bias that they associate that with good steak. But maybe eventually we can help them associate grill marks with stupid steak. No, it's not stupid. All right, so this is something, a question I often get is like, if I'm doing something one way and I know it works, like why can't I keep doing it that way? And the answer is, of course you should keep doing it that way. I like to think of it like this, like when I was a kid, I grew up in New York, we lived in Morningside Heights, and I went to school on the Upper East Side, and my mom would drive me to school, and she would always take the exact same route to school. And so that was sort of the route I knew to get to school. And that's sort of like what happens if you follow a recipe, or you learn your grandmother or your grandfather or your father's recipe. You learn one route and one direction, one way to do something. And if it gets you from point A to point B, then there's not really any reason to change it. Now, the problems can arise because, what happens when there's construction and we can't take that route anymore, or maybe we find out that in the 30 years since my mom drove me to school as a kid, they've built some new roads that are actually now more efficient, or maybe it's like, if we had just gone one street over, we could have stopped to get better bagels in the morning than we've been doing. So understanding sort of the lay of the land. I think that's sort of what science brings to cooking. Is that it helps you. It helps you sort of form your own route, and it helps you make an educated decision. And it also helps you deal with situations as they arise. And because when you don't understand what's going on, and when you only have that one route, you're kind of tied to the recipe. So that one's nice and brown on the first side. And now we're browning the second side on this one. So if we look back at this temperature and time chart, by the way, what's happening with the steak we're flipping repeatedly is that, okay, so let's just look at, like, say, one side of it right now. So it's going here. It's here for a little while. It's staying at 212 because we have to wait for the moisture to evaporate. Then eventually it's going up. And then it starts to kind of do this because you're flipping it repeatedly. And then the second side is essentially doing the same thing, right? Because we're flipping it evenly. What the other steak is doing is it's doing this on the first side. It's going up really high, and then staying right around there. It's browning. And then once we drop it, it starts to drop much more precipitously than this one because there's a much bigger temperature differential between. Let's flip this one. Between its surface and the air. So the first side eventually starts to cool down quite a bit. And then the second side does the same thing. So the entire time we're browning the second side, this first side is now cooling down. And so what that means, and you can, if you go on the internet, everyone knows what the internet is. If you go on the internet, you can find models, computer models of this that show what's going on inside the meat and how heat is penetrating it. But essentially what it means is that the one that we're flipping repeatedly, because it cools down less between flips, the heat it actually retains more heat from the pan and gives off less to the atmosphere. So it cooks more efficiently. It's going to end up cooking probably, usually around 30% faster. I'm using a thermometer right now. All right, so we're right at like 90 degrees there. And yeah, it's hard to get right in the center. But anyhow, we'll see how they go as we continue cooking. By the way, the other interesting part is that because you're not going to the temperature extremes, because you're not going to the super high temperature there, you have less of a gradient inside as well. And that's something that's pretty measurable, pretty noticeable when we're done with them. Where was I at this point? What are we about to talk about? Flipping him more, yeah. Oh yeah. I can pull them off now. I'll pull them off now. We'll have super rare steak. So both of them really nicely browned. Both of them have a nice crust in them. We'll cut into them. We're going to let them rest and cut them into them and see what they look like in a moment. Just don't mix them up. This is the flipped multiple times one, right?
Okay.
Right? Is that right? Yeah.
Yes.
Yeah. Well, yeah, you could be worried about that, but you do. I mean, you do get Maillard reaction. In fact, a lot of the times, like what happens with this one, with the one that you're browning too fast, you'll find that the Maillard reaction actually happens too fast. That it'll be really brown on the outside before it's even cooked through to the center. So it's not really a big deal because it browns well anyway.
This one's flipped.
That's the flipped, yeah, okay. And that's the less flipped. Okay, so let's go back really quickly and talk about sous vide, which is sort of the same concept of starting low, cooking basically at the temperature that you're going to be serving at, so that you can't possibly overcook the meat. The way sous vide works, you put your steak in a bag, and then you drop it into water, and this works much better than cooking in air because water is much denser. Again, a much higher volumetric heat capacity. So water that's at 130 degrees has more energy. It also transfers energy much more efficiently than hot air does. And this is something you can see where if you stick your hand into a oven that's at 212 degrees, like you can leave it in there for 5 minutes and you're fine. But if you stick your hand into a pot of water that's 212 degrees, don't do it, by the way. If you stick your hand in there, you're in a lot of trouble. One time I was, the worst kitchen accident I've ever seen was the middle of a busy Saturday night, and the guy who was on the grill, he was cooking a steak, and the grill was right next to the fryer, and he picked it up and dropped it into the fryer, and then without thinking, he just stuck his hand into the fryer, which is at 375 degrees, and that very efficiently heats things, including hands. He served the steak, but then he went to the hospital. So you put your meat inside a bag, and then you put it into a water bath. In this case, it'll be set at 130 degrees. And then instead of taking an hour or whatever it is, it'll cook through much more efficiently. So and the other good thing about sous vide is that you can, because it's at 130 degrees, you can basically store it, and it expands the window of time between the time that your meat is perfectly cooked and overcooked. If you're cooking at a very high temperature, it's just a few minutes is going to take it from medium rare to well done. Sous vide, you have hours and hours before any kind of change starts to take place, and those changes are not the changes, by the way, are not due to muscle fibers continuing to contract. It's due to enzymatic breakdown of other things. So your meat. So here's an example. Like your meat will still look completely rare. These are steaks that were cooked at 130 degrees for different amounts of time in a sous vide cooker. So after an hour, your meat is essentially like what it would be is if you cooked it in a pan or in the oven. After around 4 hours, it starts to break down a little bit, and after 24 hours, it just kind of shreds apart and turns into mush. So you don't want to cook a steak sous vide for 24 hours, but you do have that sort of really wide window, anywhere between an hour and 4 hours, and you're pretty good, which is great, I think, for it's great for restaurant service because you don't have to. Because customers are a pain in the ass, and you don't have to worry about like someone going to the bathroom or getting up for a cigarette or whatever. Similarly, like if like your cousin calls and says they're going to be late for dinner, their steak is still going to be okay. Whereas in the past you would have to hope that your cousin just liked well done meat. So some people sometimes ask me like, what are more efficient ways to sear your meat, because the faster you can sear your meat, again, the less of a temperature gradient you're going to get inside. So I think that's why I had this picture of a torch, actually. Yeah. So some people recommend using a torch. I find a torch to not actually be that great a method, and the main reason is because it's actually too intense a heat source, and it doesn't distribute heat very evenly. So if you look at your meat. And let's say like a cross section of a steak, from far away it looks like that, but really it's just sort of like the coastline of a country. You know, like it's really actually pretty uneven, right? There's parts that stick out and parts that go under. When you have a really, really high intensity heat source, the parts that are sticking out, inverse square law, you know, but the parts that are sticking out get a lot more energy transferred to them than the parts that are under here, and that difference is magnified the higher your, the faster you're transferring heat. So what you end up doing if you sear with a torch, you sort of end up singeing those little bits that stick out while the rest of it doesn't brown very well. So a torch I find doesn't actually brown very effectively. This is also, by the way, the reason we use a heat transfer medium like oil in a pan. It's because if your meat is just in contact with the metal, the parts that are actually in contact with the metal heat up a lot faster than the parts that aren't, because air is a really terrible conductor of heat. So, so the parts that are kind of sticking above the pan don't brown at all, and you get really uneven heating. So oil is a good heating medium. So oil in a pan works. I like to add a little bit of butter to the pan also, because butter adds some milk fat solids that brown, and those will trigger the Maillard reaction more efficiently. The only time I do use a torch is when I'm doing it in conjunction with a pan. In this case, I'm using a Searsol, which is a torch that has had it's a device designed by my friend Dave Arnold, and it basically is just like it turns your torch into a mini broiler. It has like a mesh on it that helps distribute the heat more evenly. It also helps the gas combust more efficiently, so that you get full combustion of the gas instead of leaving the sort of gasoline flavor on the surface of your meat. And when you do it in conjunction with a pan, the steak has a lot of oil on the surface already, so that helps it heat a lot more evenly. It ends up working. Okay, so these guys have been resting for a little while now. You want to typically rest your meat. There's a little bit of debate about this, but you want to rest your meat basically to allow the temperature gradient inside to even out. There's a debate about why this works. Some people say that it's because the juices distribute more evenly inside, so you don't end up with these pockets of high pressure where when you cut it open, the juice is kind of going to spill out. Other people say that it's just because the juices get a little bit more viscous as they get cooler. Whatever the real reason is, resting does significantly improve juice retention when you cut into your meat. The one problem with resting, though, is that, and in this case actually we're doing pretty good, but the main problem is that as you rest meat, the surface, the crust is going to diminish, and you do want, you want that textural contrast. So what I typically do is that I want the best of both worlds. I want my meat to be rested, and I want it to have a nice crust. So what I do is and I'm not going to do it today because we're going to set up the smoke detectors. I call them cooking detectors. But, we're going to set up the smoke detectors. But what I would do is I would heat up the juices that are in the pan until they're really sizzling hot, and then just allow the steak to rest, and then just before I serve it, pour those juices back over. So you get the crisp crust, but you also get even meat moisture retention inside. And I don't know if this is going to work. We'll see. I used to write, I guess I still sometimes write, that recipes are, specific recipes are kind of foolproof. And I think this is a relatively foolproof way of cooking steak. But the problem with saying something is foolproof is that you find that like no matter how foolproof something is, there's always like a bigger fool out there. And sometimes that fool is you. These days I just say that it's fool resistant. So this is a fool resistant method of cooking steak. I don't know if it's going to actually work or if we're even going to be able to see it. Which one was which now? This was the flip multiple times. Relatively even cook. Okay, so there you can see a pretty significant difference. This one ended up I pulled them out of the pan at the same time, right? So this one actually, you can see first of all it cooked faster because it is more cooked, but it is also, you don't have that bullseye pattern in there. You have just evenly cooked meat all the way through. Whereas this one we have like really overcooked meat on the outside and perfectly cooked meat in the middle. But we'll assume that I pulled them out, both of them out a little bit earlier, and so in this one you would have seen overcooked meat on the outside and undercooked meat in the center. So flipping your steak multiple times, I think, is a good thing.
So does that work on a grill too?
Absolutely, yeah.
So you stand there and just flip.
Yeah, stand there, flip, 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 flip. If you want it fast, right? It's a very fast way of cooking steak. If you want to do this sort of reverse sear method on a grill, that also works really well. So what you would do is you would, well, if you have a gas grill, you just turn on a couple of the burners, leave the other ones off, put your steak on the cooler side, close the lid, and let indirect heat, let the convection currents in there just heat the steak until it gets to close to serving temperature, then finish it over the hot side. If you're cooking on a charcoal grill, you would bank all of your coals on one side, so you would have like, if you're looking down on top of your grill, you would bank all of your coals under just one side, and then you would basically cook your steak over here with the lid down, indirect heat, and then at the end transfer it over to here. You were mentioning the difference between gas ovens and electric ovens. Similarly, there's a big difference between gas grills and charcoal grills. Not just in the way they cook, but in the way you want to cook with them, because so gas grills are designed to combust gas, and they have air intakes, and there's circulation inside there. A gas grill actually retains more heat when the lid is closed, because you're not letting all that heat out into the atmosphere. A charcoal grill will actually generate more heat when it's open, and because you're allowing the charcoal to actually combust, allowing it more access to oxygen, so it combusts more efficiently. So if you're trying to sear something on a gas grill, you always want to leave the lid closed, but if you're trying to sear something on a charcoal grill, you want to leave the lid open. So this is what happens when you have a sous vide steak, and that one was cooked sous vide, yeah. So that one, perfectly cooked edge to edge, really nice brown crust on the outside. And I think that was all the things I was going to talk about as related to meat.